Okay, let's check out the Nile River on a globe. So here's Lake Victoria. It flows north all the way to the Mediterranean Sea. So it goes from here to here. So let's check it out from the side view. Okay, here's a little mock-up of the Nile River. To make it accurate on a globe like this, it needs to be 0.008 of an inch thick. But for demonstration purposes, we'll just make it something I can actually hold in my hand. So let's lay it down across like that. And let me show you the top view. Okay, we're back to the side view. Alright, the Nile River travels north from Lake Victoria to the Mediterranean Sea. It zigzags 4,200 miles, but it travels 2,400 miles. Okay, let's do the math. Here's Google Earth. You can see it travels 2,348 miles. Let's check out the Earth curvature calculator. We're going to type in a zero viewing height and then the distance of 2,348 miles, just like Google Earth says. And our Earth curvature is 3,399,986 feet. Not bad. Now we take our Earth curvature in feet, divided by 5,280, and we get miles, 643 miles. Now we divide it by 2, and we get 321 miles. Okay, back to the side view. Okay, so the Nile River, if you lay it flat on the globe, it would be a 300 and some mile hump in the middle. That's higher than the International Space Station. Obviously, it can't go over this hump, the 300-mile hump, because gravity goes this way, right? Gravity doesn't go this way. It goes down this way. By the way, gravity is not a downward force. It's a bending of space-time. Just like you guys are going to bend what the hell I'm saying after this video. I make this video. Let's do another example. Here's this ship, right? Downward force. It doesn't blow the ship right off the planet, does it? Obviously, it can't go over a 300-mile hump. So, let's flatten it out like the topographical profile. Okay, we flatten out the Nile River. The Nile River only pitches 1 mile down. So, in fact, the last 1,000 miles of the Nile River only pitches 100 feet. So basically, we're going to lay our Nile River on top of the globe. And you can see it's floating up in the air on each end 300 miles. Do you know of anything that sticks up on the earth 300 miles? I don't think so. Higher than a space shuttle? No. Alright, so now let's pitch it so it actually drains into the Mediterranean Sea. Okay, that's awesome. Uh-oh. The one side is up like an inch. An inch on this globe is like more than 1,000 miles up. I don't think there's any mountains that are 1,000 miles high on the earth anywhere. Alright, so now if we lay it down flat, let's say we're going to shove it into the globe. And let's see what happens. Okay, here's our soft globe. See it's sticking up 300 miles. Alright, let's shove it into the globe. If we shove it into the globe and make it level where it pitches this way a mile, it's going to fill up with water. So that's out. I really don't see how this model can work. Okay, here's my model. It's a scientific fact that water seeks its own level. That makes all the oceans flat. So here's Lake Victoria. And it drains down into the Mediterranean Sea, right there. So let's place our little mock-up river on here. And we're basically going to pitch it 3/4 of a mile. Piece of cake. Obviously, if you survey it, it's going to be 3/4 of a mile higher on this side, and it's going to pitch down to the Mediterranean Sea. 3/4 of a mile. No problem. Okay, so here's the challenge. Make a mock-up of a globe with a circumference of 25,000 miles with the Nile River as stated that actually works. I would love to see it.
Hi,